Our next set of transformations is a vertical stretch and vertical compression. If you've got a whole number in front, then you're going to be stretching your function. So everything is going to get multiplied by 2. And if you've got a fraction in front, then or a number less than 1, you're going to be compressing it. So you're going to be dividing everything by 2 or multiplying by 1/2, which is the same thing. So if we think about x squared, let's think about what the table would give you. And remember, if we plug in -2, -1, 0, 1, and 2, and we square these, then we end up getting 4, 1, 0, 1, 4. But what we're doing here is we're taking all the y values times 2. So really, we're getting 8, 2, 0, 2, 8. And so these are the y values that you are plotting. So -2 is at 8, -1 is at 2, 0 is still 0, and then 1 is 2, 2 is 8. So it's been stretched along the y-axis, and it looks really skinny and thin. Here, I've got a 1/2 in front. So if we think about our chart, our original chart, what we had for absolute value was 2, 1, 0, 1, 2. But here there's a 1/2. So we're multiplying all these y values by 1/2, which would give me 1, 1/2, 0, 1/2, and 1. So I'm going to be plotting -2, 1, and then -1, 1/2, 0, 0, 1 is 1/2, 2 is 1. And so we've got a flattened out or compressed absolute value function. On the next page, we're going to be writing the equations given the words. So looking at this, they tell me it's a natural log graph and that it's shifted left 3. So remember, left and right is always opposite. So there's going to be a +3 inside the function. So what would that look like? It'll be f of x equals, and then we're going to have natural log of x plus 3. That's what they're looking for. And example 2, a square root graph, square root, flipped left and right. So if we're flipping something left and right, remember that is reflection over the y-axis. And so that means there's going to be a negative inside the square root. So this would be f of x equals square root of -x. 3, absolute value, it's going to be that. Vertically stretched by 4, which means there is a 4 being multiplied in front of the absolute value. Number 4, x cubed, well, we know what that is. Vertically compressed by 1/2, shifted down 3. So we're going to subtract 3 and have a 1/2 in front. So it'd be f of x equals 1/2 times x cubed, and then a -3 on the outside. Reciprocal graph that is shifted up 1 and right 8. Reciprocal is 1 over x. Shifted up 1, there's going to be a +1 on the outside. Right 8, remember right and left is always opposite, and that'll be inside the function. Up and down is outside of the function. So what does that mean? We're going to have f of x equals, in the function there's a -8, so it'd be 1 over x minus 8. Outside the function there's a +1, so there's a +1 outside of your fraction. Number 6, absolute value graph. Flipped down vertically. If we're flipping up and down, that's over the x-axis. There's a negative outside the function. Stretched by 3, that's also outside the function. And left 4, remember you do opposite for left and right, and it's on the inside. So what is this going to look like? We're going to have f of x equals, there's a negative and a 3 on the outside. And on the inside, there is a +4. So -3, absolute value, x plus 4. X squared, we've got x squared flipped down. So that's just like the last one. There's going to be a negative on the outside. Shifted right 6. We're going to do -6 on the inside. Down 8, we're going to subtract 8 on the outside. So that would be f of x equals, there is a negative in front, and then we've got x squared, but inside the x there is a minus 6, so x minus 6 all squared, and then there's a negative 8 on the outside. We've got square root, and it's compressed by a half. There's a 1/2 in front. Flipped left and right. If it's flipped left and right, that means there's a negative inside. And shifted up 10, we're going to add 10 on the outside. So this will be f of x equals, we've got a 1/2 in front. There's a square root. There's a negative inside with the x, and then they're adding 10 on the outside of the square root. Base e, flipped down, there's a negative in front on the outside, and up 3, we're adding 3 on the outside. So that would be f of x equals negative e to the x, and then shifted up 3 would be plus 3. On the next page, we are looking at not absolute value, piecewise functions. Piecewise functions are functions that have been cut into pieces. So here I've got 2 pieces of the function. I've got the piece where the x's are smaller than 3, and then I've got the piece where the x's are bigger than 3. And also this top one is equal to. So if I have equal to 3, it's also the top one. So here we're just evaluating, meaning plug in 0 and get a y value. First I got to figure out, where does 0 go in? 0 is less than 3. So 0 goes into the top function. So we plug in 0 to the top function. 3 times 0 is 0. 0 plus 2 is 2. Now we're going to evaluate 3. We got to figure out which one does 3 get plugged into. Well, this has an equal to symbol on it, and so we're going to plug 3 into the top function. That gives me 3 times 3, which is 9. 9 plus 2 is 11. Evaluating at 6. 6 is greater than 3, so 6 will go into the bottom function. So plug in 6. 6 minus 1 is 5. That is evaluating functions. Well, what if they want us to graph them? If we're going to be graphing functions, we're going to follow these directions. First, we're going to draw the boundary line. Boundary line. So that would be the 0 that you see. So this has been, these pieces have been cut at x equals 0. So that means one piece is going to work to the right of 0, one piece is going to work to the left of 0. So we put a dotted line at 0. 2, we're going to draw both lines, or sketch both lines, until they're on both sides of the boundary line. Now, you need to do this part with a pencil, because we're going to erase part of these lines. So I've got x plus 4. Let's graph that. It's got a y-intercept of 4 and a slope of 1. So we're starting at 4, going up 1 over 1. And so you graph that, and we're going to graph it so that it crosses the boundary and goes through the entire graph. Go ahead and do it lightly, because part of that is going to be erased. Now let's graph line 2. I'm going to call this line 2. This starts at positive 2 for the y-intercept and has a negative 1 in front of the x, so we're going to go down 1, right 1, and graph this line so that it goes through the entire graph, crossing through the boundary line. So that was step 2. Step 3, when the line touches the boundary line and there's an equal to symbol, you're going to have a filled in endpoint. If there's a less than or greater than and no equal to symbol, it's going to have an empty endpoint. So line 1 we saw is an equal to symbol, so when it crosses the boundary, it gets a filled in endpoint at 0. And then we saw the second piece does not have an equal to, so line 2 is going to have an empty circle on the boundary line. Then line 4, we're going to erase or darken the lines according to the inequalities. Line 1 is saying the line works when x is greater than or equal to 0. So I'm going to darken the part that is greater than or equal to 0, which is this side of the line. That is all greater than or equal to 0, and then I erase everything opposite of that. And then the bottom piece says it only works when x's are smaller than 0. That would be the left side of the graph is where all the values are less than 0. So I darken that section, that's what I keep, and I erase all the rest. When all is said and done, none of the pieces should overlap. You should have a piece going left and a piece going right. So that is your function for example 11. In example 12, we're going to do the same thing. Let's start with our boundary line at -1. So I'm making a dotted line at -1. I'm going to draw both graphs using the y-axis, not using the dotted line. So this starts at 6 and goes up 1 over 1. And we're going to graph that so it crosses through the entire graph. That is my line 1. Line 2 starts at 1 and goes down 1 over 1 for the slope. Starts at 1 on the y-axis and goes down 1 over 1 for the slope. And I make that line go through the entire graph. That is my line 2. Then I'm going to, on the dotted line, put filled in or empty endpoints. So this top line has an equal to symbol. So that means line 1 gets a filled in endpoint on the dotted line. And the second piece does not have an equal to symbol. So it's going to get an empty endpoint on the dotted line. And then we're going to darken and shade, or darken and erase. So the top piece works when x's are larger than -1. So that means line 1 is to the right of -1. And then I get rid of everything smaller than -1. And then the second piece only works when the x's are smaller than -1, which is to the left of -1. And then you erase everything to the right of that line. And so that is your graph for example 11, part 2.